Example problem. Four resistor loads are connected in parallel across a 100-volt, 120-volt line. Their values are 500, 200, 150 ohms respectively. What is the total currents drawn? What are the individual currents? So, of course, the rules before you solve a problem in an Ohm's law, you must draw the rough diagram. Of course, you write the formula. Now, you want to find the value of the voltage. So the formula is equal to voltage times the resistance. And if you want to find the value of the current, the value is voltage over the resistance. And you want to find out the value of the resistance, the formula is voltage divided by resistance, current. Now, since we have a 4 resistor in the problem, so the formula for finding resistance applying a Kirchhoff's first law, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Now, by substitution to the value of the formula, course R1 is 500, R2 is 200, and R3 is 100, R4 is 50. Now, since you are using this kind of formula, of course, you will use a LCD. LCD least common denominator. Now, what is the least common denominator you can use? Of course, you will use 1000. So, 1000 divided by 500 is equal to 2 times 1 is 2. 1000 divided by 200 is equal to 5 times 1 is 5. 1000 divided by 100 is equal to 10 times 1 is 10. 1000 divided by 50 is equal to 20 times 1 is 20. Now, of course, the result is 37 over 1000 or 1000 over 37. You must invert the equation. And your answer will be total resistance is equal to 27 ohms. Now, to find out the value of the total current, this is the required. So, the formula is voltage over total over resistance total. And of course, for the value of I sub 1, since it is required, the formula is E sub 1 divided by R sub 1. And same is true with I sub 2. The formula is E sub 2 over R sub 2. Now, again, by substitution to the value of the formula for finding total current, 120 divided by 27. So, the answer will be total current is 4.44 ampere. Now, for looking for the I sub 1, formula again is E sub 1 divided by R sub 1. 120 divided by 500, the I sub 1 is equal to 0.24 ampere. I sub 2, formula is E sub 2 divided by R sub 2 by substitutions. 120 divided by 200, I sub 2 is equal to 0.64 ampere. Looking for the I sub 3 and the I sub 4. Formula for I sub 3 is equal to E sub 3 divided by R sub 3. Again, by substitution, 120 divided by 100, I sub 3 is equal to 1.2 ampere. And I sub 4 is equal to E sub 4 over R sub 4. By substitution, 120 divided by 50, I sub 4 is equal to 2.4 ampere. Now, applying a Kirchhoff's law to check your current is correct. So, of course, IT is equal to I sub 1 plus I sub 2 plus I sub 3 plus I sub 4. By substitution, the value of I sub 1, 0.24 plus 1.6 plus 1.2 plus 2.4, your total current is 4.44 ampere. The same with the result of the current we have been discussed before. If you are looking to the value of the total current, applying the uh, voltage divided by the resistance. Now, to check the voltage, if it's correct, what I've said before, the voltage in parallel circuit is one and the same or equal. Looking for the E sub 1 is equal to I sub 1 times R sub 1. The value of I sub 1 is 0.24 multiplied by 100. Your E sub 1 is equal to 120 volt. E sub 2 is equal to I sub 2 times R sub 2. Value of I sub 2 is zero point 0.6 times 200. E sub 2 is equal to 120 volt. E sub 3 is equal to I sub 3 times R sub 3. 1.2 times 100. E sub 3 is equal to 120 volt. E sub 4 is equal to I sub 4 times R sub 4. I sub 4 is equal to 2.4 times 50. So your E sub 4 is 120 volt. So, false, that's true and correct. The voltage in parallel is one and the same or equal. Is that clear? Or is there any question?